Okay, useful theorem. If f prime, capital F prime, of x is equal to g prime of x on an interval I, then what is the relationship between the original functions? Well, they aren't necessarily going to be equal, but they will differ by just some constant. The constant being, so we're going to say k is some real number. Okay, the other way around is clear. If you have this equation and you do a derivative of both sides, okay, you get this. What we're talking about is the kind of harder direction. It's like, okay, if I have equality of the derivatives, the connection between the original functions is, well, they differ by a constant. So let's apply this with an example. Find the function f if it is known that f prime is a specific function and we also have f of 1 is for some reason known to be 9. Okay, so we're going to use our theorem there. We'll say, okay, yeah, I've changed my mind here. Why not change these? No, I've changed my mind again. Sorry. Try to keep that to a minimum. Never mind, small f. I was going to switch to uppercase f, but never mind. Okay, the theorem tells me is that if I have this information about the derivative, then the original function must be, well, you just do an antiderivative. Let's go slower here. The original function is the indefinite integral okay, you can put a plus c here. The theorem has a plus k, so it doesn't really matter. So this is f prime. Going backwards, doing an antiderivative, we get this. And we have this plus k here. Now, that is this in the rectangle is not a specific function, it's a family of functions. So, but we have this additional piece of information. F of 1 is 9. So we can use that to find out what k must be. But f of 1 is equal to 9. So 9, plugging that in. So this becomes 9. And then you plug in 1 to the other side of the equation over here. Plug 1 in here. squared, come on, squared, plus 8 times 1 plus k. So again, the 9 went in for f, and then the x equals 1 went in there. And there's an equal sign between the two of them. So again, 9 is equal to 1 minus 2 plus 8 plus k. So is that 9 is equal to 7 plus k. So 2 is equal to k. Now, to summarize our findings, we just say f of x equals this thing here. But now we know that k is 2. Okay, exercise to end this video. Different wording. The graph of f goes through 2, 9. And we know that f prime of x is x plus 1. Find the function f. So I'll give you the answer in the next video.